So number 7, we were talking about number 7, right? Number 7, you have the value for Q sub 0, which is 140,000. You have the value for Q, which is 275,000. You have the value for T, which is 35 years. The only unknown is R. At this level, the way you are able to find the value for R is to try A, B, C, D. Plug in 1%, which is 0.01, to see if the value satisfies the equation. If not, try 0.02, try 0.03, try 0.04, and eventually find the value for R. Number 8, suppose that poaching reduces the population of an endangered animal by 18% per year. So when you see this sentence, 18% per year, so that is decreasing, right? So this is an exponential decay problem. Further, suppose when the population of this animal falls below 50, its extinction is inevitable, owing to the lack of reproductive options without severe inbreeding. If the current population of this animal is 2,500, in how many years will it face extinction? As I said, this is an exponential decay problem, so you should have this formula ready. Let's see what we have for the variables in the equation. Initially, we have 2,500. That's the number of animals in the beginning, right? So Q sub 0 equals 2,500. And we want to know how long it's going to take the animals to be extinct. When that happens, the number of animals would reduce to 50. So the value for Q would be 50. R here is negative. As I said, that is an exponential decay problem. So R here is a negative 0.18. Again, R here is negative 18%, which is a negative 0.18. That makes the base, in the parentheses, that's the base, 1 minus 0.18, that is 0.81, is between 0 and 1. So this is, again, you see this is an exponential decay problem. And T is the only unknown. T is the only unknown. Again, we didn't learn how do we solve exponential equation of this type. So the way we figured out the value of T is to try A, B, C, D. You plug in. Okay? Yeah, so let me tell you, eventually you should have the value of T. Give me 1 second, let me see what's the value of T. You would learn that part maybe in Algebra 2. And you try to plug in the values for A, B, C, D. And it's about 20 years. You would see that's about 20 years. You should choose B. Make sure your result is the same with B, 20 years. Number 9, a toxic radioactive substance in the amount of 9 milligrams per square centimeter is detected in the ventilating ducts of an older nuclear processing building. If the half-life of the substance is 7 years, what was the amount of the substance when it was deposited 52 years ago? So this is an exponential decay problem. Good news is this section will give you the halving formula. So that would be the third formula you see in the beginning of this note. So this is the formula. This is the formula. Q equals Q sub 0 multiplied by half to the power of T over T half. T sub half here is the half-life. Are we given the value for T half in this problem? Yes, we do. We have the value for T half. The half-life of the substance is 7 years, so T half is 7. That is given. Initial value. Initially, we have 9 milligrams per square centimeter. So Q sub 0 equals, hold on, actually, in the ventilator of the, okay. So originally, we don't know. Originally, that is 52 years ago. So Q sub 0 is unknown. Q sub 0 is the amount of the substance 52 years ago. That value is unknown. Now the value of Q is 9. So actually, Q is the new value currently. So Q equals 9. Q sub 0 is the amount of substance 52 years ago. So that is unknown. We know T half is 7. What about T? 52 years, right? In the beginning, that is 52 years ago. We consider from 52 years ago until right now. So the time in years, that is 52. So you see, we have this formula, have all the known values. Q equals 9, T equals 52, T half equals 7, and the only unknown is Q sub 0. Okay, so you actually, if you have a graphing or programming calculator, you should be able to find the value for Q sub 0. You could firstly find half, that's the base, right? To the power of 52 over 7. Make sure you use a parenthesis to frame the base. Also use the parenthesis to frame the exponent, 52 over 7, and find this value. And then use 9 to divide by that value. So the formula actually is here. You use 9 divided by. I would recommend that you find this value first. Half to the power of 52 over 7. Turns out, 52 years ago, the amount of substance is about 1550.5. Number 10. A fossilized bone contains about 65% of its original carbon-14 to the nearest 100 years. How old is the bone? The half-life of carbon-14 is about 5,700 years. So we need to choose the correct formula for this problem, right? This is a halving problem again. So we're going to use the formula for halving. The third formula in the beginning of the note. Also the formula that we have used in number 9. What value do we have? We have T half equals 5,700. That is given. The half-life of carbon-14 is about 5,700 years. It's clearly given. So T half is 5,700. And right now, the amount of the substance is 65% of the original. So if the original is Q sub 0, then right now, the amount of substance would be 65% of Q sub 0. So here might be a little bit tricky. What you need to do is you plug in Q equals 65% times Q sub 0, and you would see on both sides of the equation, you have Q sub 0. You could cancel out Q sub 0. Then you would have 65% equals 65% is 0.65 equals half to the power of T over 5,700. So you can see that this is an exponential equation that you haven't learned that yet. As I said, you learned that in Algebra 2. So again, how do you find the value for T? You plug in A, B, C, D to figure out which one is the correct one. Okay, so we can try to plug in t equals 2600. We have 0.5, which is half, right? Is raised to the power, you don't wanna use a parenthesis, 2600 divided by 5700. And you have 0.72. 0.72 is a little bit bigger than 0.65. So you consider maybe do not choose A. Let's try B. Again, 0.5 is raised to the power of 2900 divided by 5700. And that gives us 0.70 is also bigger than 0.65 and not pretty close. So let's try C. This time 0.5 to the power of 3200 divided by 5700. You have 0.67. That's a lot better than A and B, right? But make sure you have the best answer. We're going to try D. This time 0.5 to the power of 3500 divided by 5700. Let's see what you have. You have 0.65, 3366, and so on. Turns out D, 3500 years, that value satisfies the equation the best. That's how you figure out this kind of problem. For the decrease problem, you might have to use the doubling formula. Doubling formula is the second formula in the note. But if you understand the halving problem, you should understand the doubling problem. All you need to do is to find the values for the given variables in the formula. T half is the time it takes for the substance to reduce the amount of the substance to half of it. And the T double is the time it takes for the substance to double its amount. Yeah, so feel free to make an appointment with me if you have a problem with the doubling problem. Thank you for watching.